So first let's look at how those factorials cancel. So on top we had n factorial squared over 2n factorial. And then we were looking at an plus 1 over an. So evaluating that at n plus 1, that would be n plus 1 factorial squared. So I'll just write it twice so I can see how stuff's going to cancel. And then on the bottom, 2n plus 1 factorial. So, we're evaluating that at n plus 1. So in each case, we are replacing n with n plus 1. And then on the bottom, again, the factorial squared, I'm just going to write that factorial twice. Make it easier to see how we're going to cancel. So there's our an plus 1 over an. Now let's flip it. So we're going to have an n plus 1 factorial, an n plus 1 factorial, a 2n factorial, and then on bottom here, when you distribute that 2, you're going to have 2n plus 2 factorial. So 2n plus 2 factorial, and then we have our 2n factorials. Okay, so let's just abandon that problem for a second and see how the individual factorials are going to cancel. So first let's look at just this part, the n plus 1 factorial and the n factorial. So n plus 1 factorial over n factorial. On the bottom, n factorial means 1 times 2 times 3 all the way up to n, right? n plus 1 factorial means 1 times 2 times 3 all the way up to n, and then n plus 1, right? It's the product of all the natural numbers up to n plus 1. So all of these cancel, leaving just n plus 1 over 1. Now let's go back. So we know how those are going to cancel. Those are each going to leave just an n plus 1 on top. Now let's see how the 2n factorial and the 2n plus 2. So 2n factorial over 2n plus 2 factorial. Oops. So this is 1 times 2 times 3 all the way up to 2n. And the bottom is 1 times 2 times 3, and we're going to count all the way up to 2n, 2n plus 1. Because remember, you count by ones. So this has 2 extra factors on the bottom, so everything cancels except you'll have a 2n plus 1 and a 2n plus 2 on bottom. So when we return up here, 2n plus 1 and 2n plus 2. Now the other thing in here was taking the limit of that. So separately, when we look at the limit as n goes to infinity of n plus 1 times n plus 1 over 2n plus 1 over 2n plus 2. Really what you've got on top is a second degree polynomial, and on the bottom you have a second degree polynomial. So you could multiply that all out, and then since they're second degree, divide top and bottom by 1 over n squared. But if we're smart about this, we can avoid doing that multiplication. Let's just multiply top and bottom by 1 over n squared. One of those n's going to each factor. So if I put the first n plus 1 over one of those n's, I get 1 plus 1 over n. If I take that second n plus 1 over the second n, I also get 1 plus 1 over n. Likewise, on the bottom, I will divide the first factor by n and the second factor by n. And so now when I evaluate, I get 1 times 1 over 2 times 2, or 1/4.